you're going to have a gene here is then you're going to have environmental inputs on that gene.
And that includes diet?
Includes what we're going to do. I'll give you an example in just a second. Let's suppose that this, yeah, we could say, we could make this an endothelial cell inside of a cardiovascular system. Okay, let's suppose that's the gene that we're talking about. And so we could say, okay, well, how much does sunlight make a difference on this? So we could have a person we could lock them in a closet, no sunlight. They get to live inside a closet with 60 watts of a light bulb their whole life. That's it. Okay. Over here, they're naked in Panama. Okay, that's how that works. And there's no trees, and there's no houses. So this person gets a phenomenal amount of sunlight. This person gets no sunlight. Now we're going to look inside at an endothelial cell inside their cardiovascular system. Now we're going to see. So this, we're going to find out if these environmental, here's a sunlight here is going to be what we call a variable. So it varies from none to the maximum amount of exposure that organism could get. This is the gene that we're interested in to see whether or not this variable impacts this gene. Okay? What we're going to now look at is we're going to see whether or not there's a range of range of outcomes. So now we're going to look at the health of that endothelial cell. Okay? So now what we're going to see is we're going to see that it's in this case, it's all going to wind up at the same place. So it won't matter. It will have almost no impact whatsoever. This is essentially what this is. So this here, this is going to be outcome. You could call that outcome 1, outcome 2, outcome 3, outcome 4, outcome 5. In other words, from I to K, if you're a mathematician. In other words, there's no difference in outcomes here. Now, what if we were looking at a light-skinned person and we were looking at a skin cell? What would it look like then? Okay. In this case, the no sunlight would have very, very little melanin. Okay. So this is going to be low tan. Okay. And then here we're going to be the highest possible tan. Okay. So this is going to be the reaction range. So the reaction range for any cell and therefore any characteristic of the so you could say, well, what about what's in your brain? Well, your brain's just cells, and so those cells can change. They're gonna the neurotransmitter composition and the way the dendrites are touching other nerve cells. That's a neural circuit. So the cells are changing. So everything about you is cellular change. So the question is, how do environmental variables, differences in environment, how do they impact what it is that we see? Okay, so that's the question. So when I was talking about the blue zones, so now we're going to say, okay, let's take the outcome. Let's take the how are you? Oh my goodness! Oh, you sweetest. Fantastic. Great to see you. Line, have a seat. So you can see that what we're interested in doing in science is to look at a variable that we think has an impact on an outcome. All right. So people that are thinking like, I don't know, what are they thinking are cool about the blue zones? What are some of those ideas?
That it's kind of set up for healthy living. There's more walking places, there's more people
Okay.
are active.
Exercise.
You might be more active.
There we go. So exercise would be a good issue. Okay, so we would say, okay, the variable is exercise. And so now we're going to look at exercise from for example, let's say essentially none, all the way to 10 miles of walking a day. Okay, so that's that would be the range of variation. And then we would look at, for example, something very, very simple that would, to measure, which would be just longevity. Okay, or we could use some other variable, like how competent is the person to walk a mile by the time they're 75 years old. And we could look at that. We could measure this thing any way we wanted to. But if we wanted to just do straight longevity, then we would look at this range of variances, variables here, and see whether or not what the reaction range was. Now, what we're going to find is that the reaction ranges with respect to most variables are very small. Okay, so exercise, for example, has a very modest effect on longevity. It's there, but it's barely there. The diet has a legitimate reaction range of about 3.6 years. Okay, so this would be here a great diet. Here is a terrible diet, and the great diet will live about 3.6 years longer than a terrible diet. Yes?
The Minnesota twin studies. The CNN medical correspondent had an article the last month where he claimed that there was a big difference in longevity, how long people live from that study.
Yeah.
And I said, a former alumni of your email, believe it. So is that true or not?
Big differences in the twins?
Yeah, life expectancy.
Yeah, it could be. In other words, because of what it is that they eat or whether they smoke. So if one twin smokes and the other twin doesn't smoke, then that's going to, in other words, environmental variables are substantial. So smoking, non-smoking is about an 8-year variance, which is huge. Diet is about a 3.6-year variance. So between those two variables, you're looking at 10 years of variance, which is phenomenal.
Okay.
Yes. So individual differences in genetics are another variable, but they're not huge when we look at people. In other words, a typical person in the U.S., if you come out of a typical gene pool in the United States, you're actually throughout the world. The typical would be if you don't die in some kind of cockamamie thing, you don't die by a taxi cab driver, runs over you in Mexico City. Okay, so if you don't, or you don't commit suicide, etc. Ruling out accidents and also potentially ruling out very early life things, some bizarre childhood leukemia, maybe you're an early breast cancer female and you contract breast cancer at 32 and you're gone by 36. So there are things that happen early in life that if we ignore those and say, okay, well, you've lived to 50. Okay, what's your life expectancy now? Around the world, the life expectancy at that point is right around 30 years. Okay, that's just basically what it is. Now, if you're a lifelong smoker, it's going to be more like 72. Okay, if you're a very healthy eater, it's going to be more like 83, and if you're a very unhealthy eater, it's going to be more like 80. Okay, so there's going to be about 3 years there. But now, if you're the blue zones issues where they pick up a moderate effect size. So if you actually look at international statistics on longevity, you're going to find that essentially, given the fact that if you live to 70, almost every country in the world, that people live somewhere between 76 and 84. In other words, it's basically all of humanity lies between those 2 points. Okay? And between those 2 points, a huge factor that predicts that is essentially, well, a big factor is genetics. So it's not going to be, like for example, you're going to find extraordinary similarities around the world because it's all triangulating at around 80. So a person in the United States will live essentially exactly the same length of time as the people in Cuba. The fact that we spend 100 times more on medical care makes absolutely no difference. The Cubans live exactly as long as Americans. Okay, so they're all sitting right there at about 82. So the so-called blue zones are sitting in places where there are naturally genetically long-lived peoples. They are looking at what they wind up looking at is they're looking for, quote, lifestyle issues. And let me tell you what, they all, don't they have a big deal about sense of community?
Yeah.
This big deal out of sense of community, okay? So it's an interesting concept. Let's measure it as a variable, okay? Let me go find a place where we got a bunch of introverts that aren't smoking cigarettes and not eating a bunch of crap, and that they live in northern latitudes, so they're a slower growing organism, and that their genes come from those kinds of places where the organisms grow more slowly, reach puberty later. And let me go see those people, and I want a bunch of them that are like totally disconnected from people and lonely and miserable. Let's see how long they live. Anybody want to take bets? Okay, I'll take a bet against Mr. Blue Zone any day of the week on that issue. I'll go find myself 1,000 lonely hearts, okay, in Northern Europe that aren't smoking and are eating vegan diets, and then we're going to find out how long they live. Anybody want to bet?
84.
What's that? Yeah, I'm going to win that bet every day. There's no question about that. So sense of community means nothing. That's not going to have any influence on these organisms. It may influence their happiness, but it won't influence their longevity. That's what we're calling majoring in minor things. There's a couple of variables here. Do you smoke and do you eat a lot of trash? If you do those two things, you're low in your life expectancy. If you don't do those two things, you're essentially optimizing your life expectancy, no matter what your social life looks like.
So quality of air would matter then, pollution would matter, because in Delhi where we come from,
Yes.
it's the most polluted city
Yes,
in the world now.
right,
So
right.
that would be akin to smoking, I guess.
Yes, that's correct. In other words, you can live in environments that are, and that's essentially the same thing as smoking. Precisely. Good. Thanks, Rakesh, for pointing that out. All right. Yes.
So one of the things though that you're kind of promising us doing like the diet this way is that even though you may live to be between 76 and 83, is you won't be sick.
Yeah.
You'll just die at a normal thing instead of being sick and then.
Yeah. What you don't
all
want to
die.
do is you don't want to die of a disease process that was preventable. Okay. And you don't want to actually be miserable in the process. So what we want to do, Alan has the charming Alan way of putting things. He says you get to live till you die.
Yeah.
That's how he puts it. Yeah, and that's what we're trying to do here is not only optimize your life expectancy, but also have a really good quality of existence.
Yeah.
And that's probably a heck of a lot more than a 3.6-year issue. That's probably a 15-year issue. It's a big deal. Yes?
What's the difference between like eating broccoli sprouts, raw broccoli, and steamed broccoli?
Nah. It's all a waste of time to worry about these things. The truth of the matter is, healthy food's healthy food, and don't worry about how it's prepared. You can worry about if it's being boiled in oil. That's